To study BJT as a switch, we have to make slight modifications to our common emitter circuit. We have introduced the resistance RB between the input Vi and the base terminal. So now VBE is no longer equal to Vi. Now for our operation, we have to utilize two modes, the cutoff and the saturation. For Vi less than about 0.5 volts, the transistor will be cut off, thus IB will be 0, IC will be 0 and VC will be equal to VCC at point X on your screen. Now to turn the transistor on, we have to increase Vi above 0.5 volts, that is beyond the point Y. The base current can be given by this equation, IB equals Vi minus VBE over RB. Notice that this VBE over here is a DC value. This VBE is assumed to be 0.7 volts. Why? Because placing a resistor RB enables us to isolate VBE and assume that a constant voltage drop of 0.7 volts is across the emitter base junction. Basically, we are modeling the emitter base junction as a single diode. This is why the resistance RB was added. Moving on, we can write the equation for IC. This is IC equals beta IB. Now note that this is only applicable when the device is in the active mode. That is, as long as the common base junction is not forward biased. The condition for which is VC should be greater than VB minus 0.4. Now we can write the equation for VC. This is same as before. Now we are going to increase Vi further. IB will be increased, IC will also increase, and VC will decrease. Eventually we will reach the point Z. This is where the transistor leaves the active region and enters the saturation region. The point Z is also known as the edge of saturation point. This is given by IC edge of saturation equals VCC minus 0.3 over R. Now where did this 0.3 come from? Look at this equation. Now VB is 0.7 and since the emitter is grounded, so we can assume VB is 0.7. Simply putting VB is equal to 0.7 here gives us VC equals 0.3 volts. So we can also write an equation for IB at the edge of saturation. This is again equal to IC edge of saturation divided by beta. This beta is for the active mode. We can also find the corresponding value of Vi required to drive the transistor to the edge of saturation point on your bottom right. Now remember what we had discussed before, that the beta in the saturation region can be set at will, and this beta is known as forced beta. This is done by increasing Vi, which drives the transistor deeper into saturation, and we reach a value of IC sat which is nearly constant. Now here the switch is closed, while at the cutoff region the switch was open. A nominal value for VC sat is 0.2 volts. These will come in handy when we do numericals, so take note of them.